Tonight we're going to talk about describing the end behavior of polynomial graphs. We won't do a whole lot of graphing. What will happen is you'll use your calculator for a rough sketch initially here, and it's probably all the further we'll get this year. But we do need to be able to describe them and describe what happens at the ends of the behavior. So as we go further and further out the x-axis to the right and further out the x-axis to the left. So as x approaches positive and negative infinity. So we're talking about the end behavior of a polynomial's graph is what the graph does as the x values approach positive infinity and negative infinity. That's our definition. So a linear function, which we've seen a bunch of, whoops. So a linear function looks something like this. It's a straight line going out that way. So as x goes to infinity out this way, these function values are going up. Okay, they continue to go up that way. So f of x would also go to positive infinity. That's what we're talking about with end behavior. This out here, as we're going to the left, as x goes to negative infinity, f of x, these values are going down further and further, f of x is also going to negative infinity. Now they won't always be the same. In some cases they are, some cases they aren't. We'll see those here as we go. But that's a linear. Quadratic polynomials, okay, we've been working with those. Let's just say we had this U shape here. Okay, so here, as x goes to infinity, f of x goes to infinity. Because as we go further and further out the right, these values go further and further up. So those go towards infinity. Now as x goes to negative infinity out the left here, these are continuing to go up. So f of x also goes to positive infinity. So that happens there. That's a quadratic. A cubic. Cubic, we have not seen graphs like this yet, but it looks something like this. And in this case, as x goes to infinity, f of x goes to infinity. Same thing here, as x goes to negative infinity, further out the left, our function values go down. They also go to negative infinity. This is just a brief sample of what end behavior is and what they look like. So if we look at this function, f of x equals x cubed plus x squared minus 4x minus 1. We have a table of values that we'll use to plot a few points. Okay, and you'll be able to use your calculators here at school, so that's why I gave you the table of values there. So we'll plot those points. Negative 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Negative 3, negative 7. Negative 2, positive 3. Negative 1, positive 3. 0, negative 1. 1, negative 3. 2, 3. And then 3, 23 goes way off the graph. So our graph looks something like that. Okay, it looks something like that. What we're concerned about is the end behavior of the graph. So as x goes to infinity, as we go further and further out this direction, f of x also goes to infinity. So that's one thing you'll have to give here. The other thing is as x goes to negative infinity, these function values also go down. So f of x goes to negative infinity. That's what we're looking at there. So again, you'll be able to use your calculator to get the table of values and also to get a rough sketch of these. And then we're concerned about the ends of the graphs. That's all we're concerned about with these. I think I have one more example for you. Yeah, one more example and then a little summary. So if we look at this next one, f of x is equal to negative x to the fourth minus 2x cubed plus 2x squared plus 4x. We have our table of values. I gave that to you. So we can plot those points. Negative 2, 0. Negative 1, negative 1. 0, 0. 1, 3. 2, negative 16. So we have some, it's a little bit different looking of a graph. We're going to come up, up, and then back down. Okay, kind of M-shaped, sort of. But as we look here, on the right side here, as x goes to infinity, these function values continue to go down. So f of x approaches negative infinity as our x values get bigger. As our x values get smaller, as x goes to negative infinity, f of x also goes to negative infinity. That's what we have there. In summary, and we'll see these, to make sure you have this down, we'll refer back to it as we see newer and newer examples. If we have an even degree, the leading coefficient is an even degree, like this x to the fourth, even degree. The leading coefficient is positive, these things happen. Okay, both function values will approach positive infinity. If the leading coefficient is negative, they will both approach negative infinity. That will always happen. And again, we'll refer back to this. These are tough to see sometimes without examples. But this leading coefficient negative, refer back to this example, this second example we did, because that's exactly what this one is. An odd degree is the first example we did, and the leading coefficient is positive. So that's this top one. As x goes to infinity, and f of x also goes to infinity. As x goes to negative infinity, f of x also goes to negative infinity. If the leading coefficient is negative, it's just the opposite. We'll have examples of each of these. We'll refer to them, and this is just something to refer back to as we do some of these problems. So that's all we have. We'll see you tomorrow.